We actually did it. We saved the ozone layer. It's probably one of the greatest environmental success stories of our time, right? A massive global crisis, and the world actually came together to solve it.
But here's the twist. What if the solution, the very chemicals we use to heal the sky, are now raining back down on us as an invisible, permanent pollutant?
Today, we're going to dive into this story of an invisible rain. We're going to uncover the hidden, unintended consequences of what we all thought was a complete and total environmental victory.
Okay, so here's our roadmap. We'll start with that celebrated solution, then we'll get into the chemical twist. We'll explore this invisible permanent rain, follow the scientific trail to see how they pieced it all together, look at the rising global tide of this pollutant, and finally, discuss what the next chapter holds. All right, so first up, let's take a quick look back at that incredible achievement. So, cast your mind back to the 80s. Scientists discovered this absolutely terrifying hole in the ozone layer over Antarctica, our planet's natural sunscreen. The culprit was a class of chemicals called CFCs, and they were in everything, from hairspray to refrigerators. In a totally unprecedented move, the world came together in 1987 and signed the Montreal Protocol to ban them. And you know what? It worked. Today, the ozone layer is well on its way to healing, a massive win for global cooperation.
But of course, to get rid of CFCs, we needed a replacement. And this is where our story takes a very unexpected turn.
So the world quickly adopted these new compounds, HCFCs and HFCs. They became the backbone of modern refrigeration and air conditioning. They did their job, they saved the ozone layer, but they came with a secret.
You see, when these replacement gases get out into the atmosphere and start to break down, they form a compound called Trifluoroacetic Acid, or TFA for short. And this substance, well, this is the main character in our story today.
And this is where it gets really tricky, because TFA belongs to a much bigger and honestly more notorious family of chemicals called PFAS. You've probably heard of them as forever chemicals. And they get that nickname for a reason. They are incredibly persistent. They just don't break down in the environment.
So you have to ask, right? What happens when you have a persistent chemical being constantly created up in the atmosphere? It has to go somewhere.
And that brings us to the really crucial question. Just how widespread is this problem, really?
The answer is everywhere. Literally, this invisible rain of TFA is falling on every single corner of the globe. Scientists have found it accumulating in our water systems, in our soil, and even in the pristine ice of the remote Arctic, thousands of miles away from any major source of pollution. Okay, but how could scientists be so sure that the CFC replacements were the main culprit? Well, it took some pretty serious scientific detective work to connect all the dots.
They used this really cool three-step process. First, they monitored the actual amount of these replacement gases in the atmosphere using a global network of sensors. Second, they used these super sophisticated computer models to simulate how those gases travel and transform into TFA. And finally, and this is the key, they validated their models by comparing the predictions to real-world measurements from rainwater and ice cores.
The results were conclusive. Lucy Hart, the lead researcher on a key study from Lancaster University, confirmed that their work provided the first definitive evidence that the TFA in the remote Arctic could be almost entirely explained by the breakdown of these CFC replacement gases. The science was solid.
And this chart from a recent Swiss study shows us exactly where the TFA is coming from. Each of those vertical bars is a different location. Now, look at the colors inside each bar. The yellow and orange sections, those represent the new replacement chemicals. As you can see, in almost every location, those two colors make up the vast majority of the bar, showing they are the primary source of this pollution.
So, this brings us to the sheer scale of the problem, a rising global tide. Now that we understand the source, we really need to grasp the volume of this pollutant and its potential risks.
And the numbers, they are staggering. One analysis estimates that just between the years 2000 and 2022, over 1/3 of a million tons of TFA were deposited onto the Earth's surface from these gases alone. And because many of these chemicals have long atmospheric lifetimes, this number is expected to keep rising for decades. Now, this is an unfolding story, and if you want to stay informed on crucial environmental topics like this one, please take a moment to like and subscribe. It really does help us keep bringing you these kinds of deep dives.
So, the big question is, why does this matter? Well, while the full health effects are still being studied, the warning signs are definitely there.
The European Chemicals Agency already considers TFA harmful to aquatic life. It's been detected in human blood and urine. And Germany has even proposed classifying it as potentially toxic to human reproduction. But for many scientists, the biggest concern is simply its irreversible buildup. It's a tide that is only rising.
And this brings us right up to today, to the next chapter, and the dilemma we face right now.
We are now phasing out the older HFCs because, it turns out, they're potent greenhouse gases. But their replacements, a newer class of chemicals called HFOs, present their own problem. While they're marketed as climate-friendly, they also break down to form TFA. In fact, some of them do it much faster and closer to where they are emitted, like from the air conditioning systems in our cars.
Professor Ryan Hosseini, a co-author of that Lancaster study, puts it plainly. This isn't a problem that's going away. The pollution is widespread, it's persistent, and the levels are still going up. We are actively adding to the problem with the very latest generation of solutions.
Ultimately, the story of TFA is a powerful reminder that our solutions are rarely perfect. In our quest to solve one environmental crisis, we inadvertently created another, more subtle one. It's a lesson that, as we face ever more complex challenges, our next fix has to be scrutinized not just for the problem it solves, but for the new problems it might create for generations to come.